We are presenting the SAFELAND project, and as you anticipated, it's aimed at enhancing the safety in case of single pilot incapacitation. So it may seem that we are out of context here, but you will see during the presentation that there are connections to the Airbus world. So it will be me, that I'm the project coordinator, and Jonas from DLR. So I will give the introduction and we will go deeper in the SAFELAND concept. In the project, the consortium has been built in order to have the experiences and the expertise that we felt were needed. So we have partners more expert in the ATM part, Eurocontrol LFV. We are partners that can provide expertise on the airborne part with Embraer and Swiss. Research centers, DLR and as Deep Blue, and we also insert some expertise regarding the legal aspects of that are touched by the project, you will see, and also EuroUC as expert in certification, but also in Airbus. As you may know, in commercial flights, normally we have at least a couple of pilots. The concept of single pilot operations is becoming more and more, let's say, popular. And one of the main problems in implementing the operational concept is, as anticipated, what to do in case the pilot is incapacitated. So is no more capable of handling the flight for a total or partial incapacitation. So we started from this question. So how to handle single pilot incapacitation? The first thing that we did was to list all the tasks that we expect will be done by the single pilot, and that when the single pilot is incapacitated should be distributed among the other actors. And we were considering air traffic controllers, remote pilots, and also onboard automation. So the first task in the project was to investigate three possible approaches. So we made like a sort of game in which we tried as much as possible to give the tasks that were accomplished by the single pilot to air traffic controllers. Then we did the same for ground station pilots, and also with automation. So we tried as much as possible and in a realistic way to assign those tasks to the automation in the cockpit. So we basically generated three alternative operational concepts that have been evaluated in terms of operational feasibility, impact on safety, impact on human factors, liability and certification considerations, and also costs. We basically consider our expertise within the project, but we have also involved external experts. We have the SAFELAND Advisory Board, and we analyzed together those three concepts, and we generated at the end one final concept of operation that was mixing the best aspects of the three concepts previously generated. And that's where we are. So we have generated a final SAFELAND concept, and we are now working on its evaluation and validation that at the end will be done with a human-in-the-loop simulation. And here I give the floor to Jonas that will explain you the SAFELAND concept.
Very much, Stefano, for the kind introduction. So my name is Joonas Lieb. I'm from the German at the Institute of Flight Guidance in Braunschweig, Germany. And as Stefano showed you in the first slide, I'm the WP1 leader. So as said, we had an internal and external feedback on the 3 variants that we proposed at the beginning of the project, in order to gather one final concept for handling the situation of pilot incapacitation and single pilot operations. And the key feedback basically was, and this is what is shown here on the slide, that the presence of a ground station that would at least monitor the aircraft system as well as the pilot health throughout the flight is required. We will need more sophisticated onboard automations that are currently not really in the aircraft and CS25 aircraft we are here talking about. So for instance, we need a system that monitors the pilot health, the single pilot health all the time. Due to liability concerns, the flight authority cannot be transferred to automation completely. So in case there are passengers on board, our feedback was from the advisory board and the internal, that's in the time frame that we are looking for, so until 2035, that there is not the possibility to transfer all the liability to automation. And one key feedback was also that ATM processes, strategies and procedures for an aircraft in emergency, what we are here talking about, should change as little as possible. And one key point that was in all the 3 variants that we proposed similar was that the ground station should be located near or next to the network operation center in order for the airline to have quite feedback and coordination with the ground station operator. Next, please. So we started basically with the nominal case. So we looked at what could a single pilot operated aircraft look like and how would the operational concept be there. And so we followed a concept that was already proposed in several research. Here is one shown, Schmidt and Korn from 2017. Where they proposed, and we aligned with this proposal, that there should be 3 different kinds of ground station or ground station operators involved in the monitoring of a single pilot aircraft. So we would have a ground station operator that would monitor one aircraft during the departure phase. We would have another ground station operator monitoring the several or multiple single piloted aircraft during cruise simultaneously. And during arrival, we would then have once again one ground station operator monitoring one single piloted aircraft in the arrival phase. So in short, basically we have during departure and during arrival one-on-one between a single piloted aircraft and the ground station operator, because we thought and think that these are the critical flight phases in a normal flight. And during cruise, the ground station operator would monitor more than one aircraft at the same time. So for instance, 3 or 4. Next, please. So this is basically a simplified view of the operational concept that I just tried to explain. So we have a single piloted aircraft where we have still a single pilot sitting. He will be in charge and in control of the aircraft all the time. And we have 3 different ground station operators who will monitor. But as we are now here looking at the nominal flight phase, these ground station operators do only monitor the flight and not interact actively. Next, please.
You have 5 more minutes for a presentation.
Okay, try to rush then. So in case of incapacitation, so here on the left side, we see the nominal case. So what happens when there is the incapacitation? Next, please. So the single pilot is incapacitated. Now the control comes from air to ground, basically. So the cruise ground station operator will take over the duties of the single pilot for a short period of time, because we have, and now next slide, please, a standby ground station operator especially for these kinds of incidences, ready in case of there is this emergency. So we say the cruise ground station operator will hand over the duties to a standby ground station operator who will then land the aircraft safely. Next, please. So which phases do we anticipate from takeover until landing? Next, please. First, the onboard system detects pilot incapacitation. After that, the aircraft follows the flight plan. The aircraft issues a squad code and ATC is there to clear the airspace. After that, the cruise ground station takes over the control and stabilize the flight if needed. Then we have a handover from the cruise ground station operator to the standby ground station operator. After that, the automation provides a list of suitable airports, and then the standby ground station operator decides for a diversion airport. And after that, the ground station operator requests clearance for the emergency landing, and the emergency landing will be done by the onboard automation based on autopilot data that is already in the aircraft. Next, please. For the case the incapacitation happens in the TMA area, we have a slightly different approach, because if you remember at the beginning, I said there we have a one-on-one between the arrival ground station operator and the single piloted aircraft. So there already the ground station operator has the total situational awareness of this aircraft and is able to take over the responsibilities to control the aircraft in case of incapacitation. And then next, please. The takeover phases are a little bit different, so quite similar actually, but there is not the handover required anymore. So we say the onboard automation still detects the incapacitation, the aircraft follows flight plan, issues the squad code, and ATC clears the airspace. But now the arrival ground station operator takes over control, and this ground station operator requests clearance for emergency landing, and the emergency landing will be done based on the autopilot input. Okay, next, please. So the key attributes basically from our concept are we have 3 different ground station operators, one for departure, one for cruise, one for arrival. This concept relies on more sophisticated onboard automations that currently not existing in the aircrafts. So especially some kind of a pilot monitoring system. The handover procedures are closely aligned with current requirements for remotely piloted aircraft. For instance, proposed by ICAO or URClearED. So we try to be aligned with them. Our concept does not see any significant changes on the task and responsibilities of ATC. This was one of the main feedback we actually got from our advisory board. The remote pilot is able to control multiple automated UAS simultaneously, so during cruise. And the ground station operator is not expected to operate the aircraft under manual control. Basically, what he is doing is giving commands to the autopilot on board of the aircraft. Next, please.
If you can wrap up a little bit now, it's almost time.
Sure. So the next events. We have on end of September, the 11th SESAR Innovation Days. We have the final concept in May 2020. We will have, as Stefano said, a real-time simulation for that. And the final dissemination workshop is in November 2022. And we have already 2 public deliverables. So please visit our website and you can find them there. There's also the final concept in its totality. And we have some, of course, Twitter, LinkedIn, ResearchGate, and our own project's website. So thank you very much.
Thank you very much to both of you for this presentation and respecting the timeline. Now I'm looking back to the audience to see if there are any questions through raising the hands. Come on, one for Stefano. There seems to be There seems to be none. There is one raised hand I see from Hermano. Please go ahead.
Yes, thank you for the presentation, Stefano. I would like to ask if you have considered the legal problems that are in these interesting topics, and if you can tell us something in this respect. What are the most heaviest problems in this respect? Thank you.
Yeah, luckily in the consortium we have EWI, University of Bologna, that is expert in analyzing legal aspects of complex systems, and especially what will be the legal problems when you introduce new technologies or when you change complex systems. And we will find on the website let's say preliminary analysis, and in the final report there will be a complete analysis. And the main problem is that according to the legal rules for aviation especially, not having a responsible on board, it's a problem. Meaning that to have someone accountable for the conduct of the airplane, he should be able to act on the flight in a way that it's not so easy when you do it remotely. And the other problem was the one that Jonas already anticipated about automation. So one limit that we had in giving some, let's say, tasks to automation was that then it was really difficult to indicate who was responsible in case of automation failure. So that very briefly were the two main problems. And again, at the end of the project, there will be the final report in which we go deeply in the analysis of the legal implication of this type of concept.
Thank you very much, Stefano.